In this video for section 2.7, we're going to introduce the idea of an inverse of a function. So if we have two functions, f and g, if we calculate the composition f of g of x, and if things cancel out and it ends up just equaling x by itself, and if we calculate the composite function g of f of x, and things cancel out and that also just equals x, then g and f are inverse functions. Inverse functions are sort of like opposite functions. They undo one another. And we have a notation for the inverse of the function of f, and that's f with a -1 sort of in the exponent position. That's not an exponent, it's a notation for f inverse, or the inverse function of f. So we're going to look at example 1 from the textbook. It says to show that each function is the inverse of the other. So what we need to calculate first is f of g of x. Then we need to calculate g of f of x. So f of g of x means that we plug g into f. So I'm going to replace x with x minus 2 over 3. So 3 times x minus 2 over 3 plus 2. Now looking at these 3's here, since they're the same number, I can just cancel them out. If they were not the same number, what I would need to do would be to distribute this 3 into whatever is in the top of the fraction. But since they're the same, I can cancel them out, and that leaves x minus 2 plus 2, and minus 2 plus 2 will also cancel out, so this will just equal x. So now, let's calculate g of f of x. So now we're plugging f into g. So I'm going to replace this x with 3x plus 2. So that'll be 3x plus 2 minus 2 over 3. Now I have this in parentheses here, but I can just take those parentheses out because I'm not multiplying it by anything. I don't need to distribute anything or anything like that. So this is just 3x plus 2 minus 2, and the plus 2 minus 2 will cancel out, leaving me with 3x over 3, and the 3's cancel out, leaving me with just x. So if both of the compositions result in just x for the answer, then that means that yes, the functions are inverses. If you result in anything other than just x, then the functions are not inverses. So next you should look at checkpoint problem number 1. Do this in your notes, check your answer, and then move on with the video. Next we're going to talk about how to find the inverse of a function, and the process is as follows. First we replace f of x with y, then x and y switch places. Then we solve for y. Lastly, we replace the y with f inverse x, this notation. So we're going to do example 2 from the textbook. Find the inverse of f of x equals 7x minus 5. So first we replace f of x with y. So y equals 7x minus 5. Then x and y switch places. So now I have x equals 7, y minus 5. Now I want to get y by itself. So to get y by itself, first I add 5 to both sides. So x plus 5 equals 7y. Then I divide both sides by 7. And I have y equals x plus 5 over 7. And lastly, I'm going to use the inverse function notation. F inverse of x equals x plus 5 over 7. The way that you'll see this in the homework, you won't have to type in this f inverse of x. It'll give you f inverse of x equals, and then you'll just type the rest of the function into the box. So x plus 5 over 7. So next you should look at checkpoint problem number 2. Do this in your notes, check your answer, and then you can do the homework.